polymerase poisons. We have two classes of compounds for topoisomerase poison. So one is the camptothecins. So camptothecins are 5 cyclic rings are there. There are 5 cyclic rings. So that is why pentacyclic. And one of the ring is the lactone. It's a cyclic ester. So here also 5 cycles. So ring A, B, C, D, E. And the fifth ring is as a lactone ring. So that's a pentacyclic lactone type compound. They are isolated from natural source. That's why we call it as an alkaloid. Alkaloid means natural compound with at least one nitrogen atom. So both compounds, nitrogen atoms are there. So it's a natural alkaloid. We have two compounds in this category. That is topotecan. Topotecan is the substitution, that amino substitution at carbon number 9. And irinotecan, the substitution at carbon number 10. That's the difference. Okay. So the 9th carbon substitution is topotecan, and irinotecan is the 9th carbon substitution. That is the 10th carbon substitution is irinotecan. There are two compounds, and irinotecan and topotecan this category. And the photophytotoxins also comes to this same category. The photophytotoxins chemically is a this type of the 4-member ring is called lignan, and one of the ring is the cyclic ester lactone. So these compounds are classified as a lignan lactone. The previous one is the pentacyclic lactone. So all those 4 are summarized here. So topotecan and the irinotecan both are the camptothecin type alkaloid. So camptothecin type alkaloid, and etoposide and tiniposide, and those two are epipodophytotoxin type chemical. This is a natural product classification. So epipodophytotoxin type compounds. So the second one is not an alkaloid. The first two are alkaloid. Those are not alkaloid. And chemically they classified as a pentacyclic lactone. So that's a 5-member ring. The last ring is the cyclic ester, is a lactone. That's also pentacyclic lactone. And it's a natural product classification. This is a lignan fragment. So the lignan with the lactone, lignan lactone, and that's also lignan lactone. So irinotecan is an active compound. It's a prodrug. So the promoiety, that's a fragment, is a promoiety. So the promoiety is attached to this compound to increase the water solubility. So this amino and this two, the pyridyl and that's saturated pyridyl. So these two rings are attached to increase the water solubility. So once that compound is metabolized, the ester bond will be cleaved. Thus will become a hydroxy. 10-hydroxy is the active metabolite. That is SN38. SN38 nothing but removal of this functional group, promoiety, and add hydrogen. So that is a hydroxylate, carbon number 10. That's the active metabolite. And again, this is not a prodrug, and one of them here is prodrug. That is the phosphate. Etoposide phosphate is prodrug. The phosphorus, the phosphate group is attached to increase the water solubility. Here also the promoiety is attached to increase the water solubility. So only the two compounds are prodrug, the irinotecan and etoposide phosphate, that is a prodrug. Chemically it's a weak base, and this is the nitrogen atom is there, and we have again nitrogen atom here and here, so it's a weak base. And the one commercially available is the hydrochloride salt. So irinotecan hydrochloride is available commercially. It's a hydrochloride salt. And this is also chemically is a weak base. So we have a nitrogen atom weak base, so hydrochloride salt is commercially available. So one etoposide, the first one is a neutral compound. It's not a weak base, there is no nitrogen atom in the molecules, is a neutral. The one is a phosphate analog is acidic compound, because the phosphate is an acidic functional group. and adipocyte is again is a neutral compound. So irinotecan, tocotecan is a weak base, and adipocyte phosphate is an acidic compound, and adipocyte and adipocyte both are neutral compounds. Chirality, and there is one chiral center in the molecule, and that's the chiral carbon, and the one commercially available is the S isomer, and the same chiral center here, one chiral center, the commercially available is the S isomer is active, and these two, all three are chiral because they have the sugar moiety, those are chiral carbons. We have several chiral centers including the one in the here, 1, 2, and then this all carbons are chiral carbons. So there are several chiral centers in the molecule. So metabolism of irinotecan, that metabolism is, one of the metabolism is cleavage of this ester bond, that we get the hydroxy metabolite. The hydroxy metabolite is nothing but that is a SN38, that is a hydroxy metabolite. The hydroxyl, once that hydroxyl is introduced, then it can undergo for the glucuronide and sulfate conjugation, and that's the phase 2 metabolism. Irinotecan that inhibits cytochrome 3A4, so any compound which metabolize 3A4, so those combinations we get a direct interactions. Tocotecan also inhibits cytochrome 3A4, and the possible metabolic reaction is cleavage of that alkyl group, methyl group. So that is one of the methyl groups. So ND alkylation is the metabolic reaction, and followed by glucuronide conjugation. That's a phase 2 metabolism. Adipocyte. So the possible metabolic reaction, both are same metabolic reaction. So lactone hydrolysis. So that is a lactone ring cyclic ester. The hydrolysis of lactone. So we get a hydroxy carboxylic acid. So when you hydrolyze here, and this become a hydroxy, and this side become a carboxylic acid. Hydroxy carboxylic acid. So hydroxy acid that we get after lactone hydrolysis. That hydrolyzed lactones are inactive metabolites, and adipocyte also inactive metabolite. So only one active metabolite. Remember that SN38 is the active metabolite. The remaining all inactive metabolites. And these two are teratogenic compounds. Those adipocyte and adipocyte, and again the adipocyte phosphate. Those all three are teratogenic compound. And here we get a direct interaction with cytochrome 3A4.
Which one is active metabolic?
The one here, the SN38. So hydrolysis of this ester, we get a 10 hydroxy analog, that is the SN38, that is the active metabolite. So the next one we have, next class is called antibiotics. So antibiotics, we have a doxorubicin and eberubicin and valrubicin, danarubicin and idarubicin and mitoxantrone. That is the structures for the antibiotics. So those all are summarized, those antibiotics here. So antibiotics used for the cancer treatment. So all those compounds, we have a sugar moiety attached. That's a sugar moiety. So the sugar moiety attached with, there is no sugar moiety in the last compound. Okay. So the sugar moiety attached, that's a glycone, and that's a A-glycone, non-sugar moiety. Those two are connected with the ether bond, that is a glycosidic linkage. So those are the fragment for the A-glycone part, that is the anthraquinone. So 4-member ring with there is a diketo, that's a quinone, anthraquinone, and that's a sugar. So that's two are connected with a glycosidic bond. So anthraquinone glycoside. So that's also anthraquinone glycoside. So the all are classified as a anthraquinone glycoside. The last one, there is no sugar moiety attached. So that's only that anthraquinone moiety is attached to this compound. So there is a anthraquinone. The remaining all glycoside type compound. The sugar attached here is So that is a that also mean there is a sugar attached. So all are so amino sugar is attached to this compound with a glycosidic linkage. The mechanism is all are same. It's non-covalent interaction. So the non-covalent interaction is not a reversible interaction like hydrogen bonding and hydrophobic and van der Waals. Those ionic interactions, those are the non-covalent interactions. So those are the reversible interactions. So non-covalent interactions with the DNA molecules. That's the same mechanism for all those analogs. Doxorubicin and epirubicin both are same compound, structurally very similar compound. So only difference, the sugar moiety, here the sugar moiety is alpha hydroxyl, the 4 prime, the alpha hydroxyl. Here we have a sugar moiety, the opposite stereochemistry is a beta hydroxy. The remaining structure is exactly the same. So epirubicin is nothing but an epimer of doxorubicin. So this AB is nothing but it's a epimer. Epimer is when you have a several chiral center, when you switch one of the chiral center, that is called epimer. So epirubicin is a epimer of doxorubicin. Only the change in the one of the stereochemistry. So alpha hydroxy to beta hydroxy. Valrubicin, that is a VAL, that is a valine amino acid is attached. So sorry, not valine, valeric ester. So the ester bond is with valeric acid. So this is not a valine, sorry, it's a valeric ester is attached to this compound. So that is the reason is called valrubicin, and epirubicin is an epimer. And one of the major drawback this type of antibiotic is cardiotoxic. So the cardiotoxic, the compound is not a cardiotoxic compound, the metabolite is cardiotoxic. So we have a keto functional group, and that's a keto. This is not because of the valeric ester, the possibilities are very less, but this keto group is there, and this keto group is metabolized with that hydroxy analog. Keto is converted to hydroxy analog with aldo keto reductase. That's a phase 1 type metabolism. So keto converted to hydroxy, that is called doxorubicinol. So doxorubicin is a keto, that is a active drug, and after metabolism we get a hydroxy analog, that is a doxorubicinol. The doxorubicinol is cardiotoxic metabolite. Epirubicin, again that we get a the reduction metabolite with aldo keto reductase, that is a conversion of ketone to alcohol. Compared to doxorubicin, this is 30% less cardiotoxic, and valrubicin is less cardiotoxic. But daunorubicin, that is also toxic, cardiotoxic because of the keto functional group converted to alcohol. So the cardiotoxic metabolite is called daunorubicinol. When you have alcohol, that is OL, daunorubicinol or doxorubicinol, epirubicin, those are the cardiotoxic metabolite. So these two are structurally a little different. Those are called lipophilic metabolite, and there's one of the methoxy group is missing here. So those analogs we have a methoxy group at carbon number 4. That methoxy group is missing here. There is no methoxy group. So lipophilic. So this is good for the cancer cell penetration and suitable for oral. And this is not a cardiotoxic because we don't have the ketone functional group. That's why it's not cardiotoxic. The possible metabolism for that mitoxantrone, that it goes ND alkylation, the removal of the alkyl functional group, and deamination and removal of, so once you remove the alkyl, then the amino group also removed, that's the deamination, and followed by the oxidation, and when you remove the deamination you get that aldehyde, that is the oxidation, and that's a chiral compound. The other remaining all are chiral compounds. Doxorubicin chemically is a weak base. We have a that's a NH2 is there. It's a amino group, primary amine, weak base. Epirubicin is a weak base. Here the amino group is converted to amide, so it's not a weak base, it's a neutral compound. And here we have a primary amine is a weak base, and primary amine weak base, and there also we have a secondary amine is a weak base. So all are weak base except valeribucin, that's amide, so it's a neutral, not a weak base. Doxorubicin and T of is 40 hours, and we have a liposomal formulation for doxorubicin that is called doxil. Doxil is a liposomal formulation for doxorubicin. The half-life for the liposomal formulation that is a 55 hours. And this is available as a polyethoxylated castor oil with ethanol. That is the one used for the formulation. And danarubicin formulation is available with citrate salt with the liposomes. That's a commercially available formulation. The half-life for the idarubicin that is 22 hours. The half-life for the idarubicinol, that the alcohol metabolite, that is half-life is 45 hours. So all are glycoside except the last one, that is not a glycoside, that's androquinone. The remaining all androquinone glycoside. The sugar moiety attached is danosol, L is levorotatory danosamine, and mechanism is non-covalent interaction as a reversible interaction, and this is an ephemer of this one, that is once stereochemistry is changed. And remember that is a cardiotoxic metabolite. In several cases we get the cardiotoxic metabolite, that is a rubicinol. That alcohol metabolite is cardiotoxic. Next one is the mitosis inhibitors. We have 2 paclitaxel and docetaxel and carbazitaxel and vincristine. Those all 4 are classified as a mitosis inhibitor. So paclitaxel, that's a natural compound. So it mentions the natural compound with an amino functional group is an alkaloid, and this fragment is a terpene, it's a diterpene fragment. And so when you have a compound with diterpene, that is 20 carbon analog. So diterpene alkaloid. Docetaxel also diterpene alkaloid, and carboxydoxin also diterpene alkaloid. And vincristine is not a terpenoid compound, it's an indole. That's a fragment is indole. That's 2 indole fragments are attached. So it's an indole alkaloid. It's also natural compound and isolated from the Catharindus roseus. It's a natural compound. There are 2 fragments in vincristine. So one is catharindine. This fragment is catharindine, and the other one is a vindoline. So those catharindine and vindoline both are connected with carbon-carbon bond. So there are these fragments are connected together. Both are indole fragment is connected together. It's an indole alkaloid.
Excuse me, could you show the diterpene structure?
See, when you have a terpene, you have 5 carbon unit is called terpene. So so 1, 2, 3, no, 1, 2, 3, 4, 5. So this is called 5 carbon unit. That is called isoprene. This is called isoprene units, right? When you have 2 isoprene, so 2 5 carbon, 2 isoprene units called terpene. And when you have 3 isoprene units, so this is a unit. So those are mixed together. We have a different strategy. So when you are, this is called head and this is called tail. So they may be attached, head to get attached, head to tail attachment. So when you have 3 isoprene unit, we call sesquiterpenes. Sesquiterpenes. And when you have 4 isoprene units, that is called diterpenes. So 4 isoprene units, we have 20 carbons. So those are rearranged inside this fragment, that is called 20 carbon fragment, that is called diterpene. So it is not like a straight attachment, those are rearranged. When they rearrange, some of the carbons are removed. So but this 4 isoprene units are used to make this the parent compound. So that's why we call diterpene.
What is the third one?
Sesquiterpene. Sesquiterpene means when you have 3 isoprene units of sesquiterpenes. So the mechanism is binds with beta tubulin. When a compound goes to 3-dimensional structure, we get a butterfly conformation. That butterfly conformation is important for binding with beta tubulin. Compared to paclitaxel and docetaxel, and this is a lipophilic, and the docetaxel is the hydrophilic analog. So they have modified some of them. So one of the modification, they changed that alkyl to the aromatic to alkyl, and then one of this ester is cleaved. So you have a ester here, the ester is converted to hydroxyl, that makes the compound is hydrophilic, and that's the ester is lipophilic. Carboxytoxal is a methoxy analog. So when you have a ester and then there's a hydroxy, and this one is the methoxy. So methoxy also lipophilic analog. Overall, this is an lipophilic compound. It's an indole alcohol. Metabolism. Paclitaxel is metabolized with cytochrome 2C9. We get a 6-hydroxy paclitaxel, that is the metabolite. And docetaxel metabolized with 3A4. We get a hydroxy docetaxel. And carboxytoxal is metabolites. This is we get a 3 metabolites of metabolites we get from carboxytoxal. So one of the metabolite, carboxytoxal, one of the metabolite is docetaxel. We get 3 metabolites, one of them is docetaxel. The docetaxel is nothing but metabolite of carboxytoxal here. Vincristine also metabolized with 3A4. So those are metabolized with cytochrome 3A4. So we have a drug-drug interaction. We have a combination of the drug which is metabolized with same metabolic enzyme. Only the paclitaxel is 2C9. So this one can cross the blood-brain barrier, carboxytoxal, the methoxy analog. Mechanism inhibit mitosis. That's a mechanism for those analogs. All are chiral compounds. We have several chiral centers molecules. So all are chiral. So this one inhibits cytochrome 2C9. So any compound which metabolizes with 2C9, we get a direct interaction. So 17 alpha ethinyl estradiol is metabolized with 2C9. So we have a direct interaction, combination of paclitaxel with ethinyl estradiol, and paclitaxel with diazepam also we get direct interaction. That's metabolized with 2C9. This inhibits cytochrome 3A4, and 3A4 is an important enzyme for those azole antifungal agents, erythromycin, and cyclosporine. So when you have a docetaxel with the ketoconazole, fluconazole, itraconazole, we have a direct interaction. And docetaxel with erythromycin and cyclosporine, those also get direct interaction. because of this inhibit cytochrome. 3A4. Carboxydoxal is suitable for docetaxel resistant cancer. So one of the recommendation. These two are teratogenic, paclitaxel and carboxydoxal. Two are teratogenic. Paclitaxel is available as a 50% alcohol and 50% polyoxyethylated castor oil. That is the formulation used to make with paclitaxel. And docetaxel is available as a polysorbate 80 formulation, and that's also polysorbate 80. And vilcristin is the weak base, so available as a salt with sulfuric acid. So sulfate salt, vilcristin sulfate is available because weak base make a salt with strong acid, sulfuric acid. So sulfate salt is available. 3 are terpene alkaloid, 1 is the indole alkaloid. Remember that butterfly conformation is important for the paclitaxel. 2C9 inhibitor, remaining is this one is a 3A4 inhibitor, and 2 compounds are teratogenic. So the final exam, we have 5 questions from today's lecture and 7 from the old material. The old material, so the 7 questions from these compounds, okay, and the 5 from today's lecture. So total 12 questions. Yeah.
Can you go back to the final? Thank you.
Teniposide, which function does this molecule have? Is a DNA cross. Is a DNA cross-linking agent, anti-metabolite, topoisomerase 2 alpha poison, interstrand cross-linking agent or intrastrand cross-linking agent, DNA alkylating agent, interact with tubulin. So what is the mechanism for this compound? C, yeah. Topoisomerase 2 alpha poison, that is the those all are topoisomerase poison. Yeah, some of them are old. These 2 are the previous class compound. So this is a topo alpha poison, topoisomerase poison, and docetaxel is the interact with beta tubulin. Okay, so that is the docetaxel. That is a butterfly conformation is important for docetaxel activity.
said MedChem is what?
Interacting beta tubulin. That's the mitosis inhibitor. That's the one here. Binds with beta tubulin. Those all are same. So when it binds with beta tubulin, so you inhibit the mitosis. That's the mechanism for us. So is nitrogen mustard? No.
F.
Is an indole alkali? No. Is a prodrug? No.
No.
No, not a 2C9. Acrolein is not a toxic metabolite of docetaxel. No. It's a diterpene alkali. F is right.
Yes.
Inhibits cytochrome 3A4. That's right.
Yes.
And is it terptogenic? No. And greater water solubility than paclitaxel. Yes, because of this hydroxy. Induces cytochrome 3A4. No. Nitrogen mustard? No. Amphoteric? No, is a weak base. So it's a diterpene alkali, inhibits cytochrome 3A4. The compound has a greater water solubility compared to the paclitaxel. Because paclitaxel we have a ester functional group. Here we have a hydroxyl that makes the compound has a better water solubility compared to the paclitaxel. And that inhibits cytochrome 3A4, and that's a terpene alkali. It's a diterpene alkali.
Bees.
B is right, is an indole alkali. F is right, is a weak base. So this is not a terptogenic, only this two are terptogenic. Paclitaxel and carboxytaxel is terptogenic, not vincristine. So vincristine is not a terptogenic compound, and it's not a DNA alkylating agent, it's not a DNA cross-linking agent, it's not a weak acid, it's a weak base because we have the indole nitrogen, that is also nitrogen, so it's a weak base. So available as a sulfate salt, so it's not a weak acid. This alkaloid is isolated from Catharandus roseus. Yeah, that is a plant. Compound is isolated from Catharandus roseus. I think we may have it in this. Yeah, it is naturally isolated from the plant Catharandus roseus. It's not an amphoteric compound. So the right answer is indole alkali and is a weak base and isolated from Catharandus roseus. Yeah, it's a prodrug. This is hydrolyzed, so we get a hydroxy is the active metabolite. So when this is hydrolyzed, we get the SN38 is the active compound. So it's a prodrug. SN38 is an active metabolite of inotecan. These two are right. The next one is a camptothecin type compound, that is right. And is an active metabolite is SN, this hydrolysis, this we get a hydroxy. Carbon number 10 hydroxy analog is the SN38, that is right. Huh?
One chiral center.
Yeah, that's the chiral center, one chiral center. S isomer is active and is a weak base might attach to this compound, and it's camptothecin analog. So that we have in the slide, those are camptothecin analog, these two are camptothecin analog, these two are camptothecin analog. And SN38 is the active metabolite of irinotecan, that we have this detailed. SN38 is an active metabolite. And chemically is a weak base, so we have a nitrogen, that's a weak base. Compound has one chiral center, SO isomer is active, and the compound inhibits cytochrome 3A4, so that's also the right answer. Both are ligand and lactone analog, so A is right, it's not an alkaloid. Which one is more lipophilic? Is it etoposide or adiposide? So the lipophilicity and potency is this is so when they attach the adiposide, it's nothing but the thiazole group is attached. So instead of a methyl here, there is a methyl group and there is a methyl group. This methyl group is replaced with thiazole. The reason for replacing thiazole, that increases the lipophilicity. So not a thiazole, thiophene. Thiazole means you need a nitrogen. So only there is no nitrogen. So it's a thiophene. So 5-member ring with sulfur, that's the thiophene is attached. So thiophene increases the lipophilicity. So when they change the methyl to thiophene, the adiposide is 10-fold more potent than the etoposide. So increases the potency, 10-fold more potent, and increases the lipophilicity.
H.
Yeah, H is right. G, the adiposide is more potent than etoposide. G is right. And adiposide is more lipophilic than etoposide. E is right. And both are not a camptothecin analog. Both are ligand lactone type compound. So both compounds are ligand and lactone type. That's a ligand fragment and that's a lactone ring. Cyclic ester, so lactone ring. And both are, that's adiposide is lipophilic than etoposide. The reason is adiposide is thiophene ring is attached. And adiposide is more potent than etoposide. That's 10 times potency. That is also the thiophene ring is attached because of this more potent. And this is the teratogenic compound. That's also right. We have this.
B.
Yeah, androquinone glycoside. Sugar, and this is androquinone.
F.
Is a weak base, that's right. F is right because that's the primary weak base. It's available as hydrochloride, so the compound should be a base. That's why the hydrochloride salt is available. So weak base is right. Sorry, this is rubicin. Okay, this thing is OL is not required here. So doxorubicinol is a cardiotoxic metabolite of doxorubicin. That is right. This is not all. Okay, doxorubicinol is the cardiotoxic metabolite of doxorubicin. That's a G is right. And toxil is the liposomal formulation of doxorubicin. That is also right. And that's all. So, is anthraquinone glycoside and is a weak base. There is a primary amine, is a weak base. Doxorubicinol is the cardiotoxic metabolite of doxorubicin. And toxil is the liposomal formulation of doxorubicin. That's the right answer. So toxil is a liposomal formulation. This is not all. So it's doxorubicinol is a cardiotoxic metabolite of doxorubicin. There is no oil here. It's a weak base. And anthraquinone glycoside.
H.
It is an antibiotic and neoplastic type compound. No, it's not a triterpene.
It's A.
Yeah, but it's a diterpene, not. It is it's a diterpene, not a triterpene. It's yeah. It's a diterpene. Okay, sorry, here is triterpene. This is not right. It's a diterpene. Okay, so that's last 5 questions from today's lecture and 7 from old material from exam 1 to 5. So 7 questions from this compound. So Marceline, and we will go through those numbers. This is signing.